So, Hackathon demo time. Thanks a lot again for joining in. It's been a really great journey so far the past couple of days, and I'm really looking forward to see what everyone came up with. And just to go back through to the overview of the hackathon. So these are the requirements, and this is also where Binke and Luca will judge your work on. So first thing, it needs to resolve an actual problem that we see in our lives. So that's the first thing. It needs to be an end-to-end use case. So it needs to start from the device and it needs to end up somewhere in the cloud where you either visualize, process, or act on the data initiated by the end device. The presentation needs to include a live demonstration. I put it between brackets, but I think some also, and I've heard that they pre-recorded this demonstration and want to showcase that during the presentation. So that's fine for me as well. So there are quite some groups gonna present today. So we limit each presentation to 2 minutes, and eventually there will be one big winner. After those 2-minute presentations, it might be that Binke and Luca have a question. Just going to be 1 or max 2 questions per group to define if you really thought about this product thoroughly. So, Binke Gieseman, Luca Mustafa, oh, sorry for the typo, Luca. So, Binke, initiator of the Things Network, CEO of the Things Industries. So he's been running this business for, I think, 6 years now. So we've seen quite a lot of use cases succeed and many fail. And Luca is the CEO of IRNAS, and he is an engineer and has seen many projects and have actually initiated and worked on many projects on the technical side. So we know him from an initial interview that we've seen earlier this week. And he's done a lot of cool stuff about tracking animals, protecting endangered species, but even you've seen him on analyzing sensors. So it's really cool, really advanced stuff that he's doing. So I think mainly on the technical side, he might have some critical questions during this hackathon demo. So these are the teams, these are the presentations. So we have 13 presentations in total. So most of them are individual presentations, and actually we have 1 team, which is actually quite a big group. If you still want to present, but you're not on this list, make sure you send a message in this event chat, and I'll still add you to the list. And we're actually gonna have a few pretty cool prizes, which I'm gonna share with you. So the winner has a prize, and the prize is, to start off with, you have this very nice custom-made limited edition TTN t-shirt that will be sent to your home address. So that's the first one. In addition, you will get a gateway. The Things Indoor Gateway will be sent to your home. And eventually the winner also gets a full access ticket to our conference that is happening in January. So you have a physical ticket, so you can join in Amsterdam. If you somehow manage to not be able to visit Amsterdam, then the ticket is also worth to join in the event virtually. So this is actually really something that we give away. So before we start the demo, Luca, anything you want to say to the students? Is there anything you want to pay particular attention to?
Yes. So for all of these demos, really the end utility. How is this useful? Is the first question that always arises. So I would really love to see short, concise sentence. This solves this problem, and I believe it's great because A, B, or C. Like, really, what's in your thoughts? What does this solve? And then we take it from there.
Cool. All right, that's clear. Binke, anything you wanna share, or you paying specific attention to?
Yeah, sure. Next, of course, Lucas said, like, it has to solve a real problem, and what we've seen is that successful use cases solve it in a simple way. Like, it can be technically very sophisticated, but it has to be simple to deploy, because you've seen that go-to-markets are one of the biggest challenges in our industry, and so yeah, it also has to find adoption by users. And that is, yeah, the first one is solving a problem, and second one, it's easy to apply.
All right, great. Thanks for sharing. So I would like to invite the first presenter to come in this call, so he can join this top right. You can click this button, share audio and video. I would like to announce the first presenter, which is Marcus Spiegler. So Marcus Spiegler, click the button and I'll give you access to this call. And at some point I'll give you a go, and then you can start your 2 minutes. All right, go Marcus. Still waiting for you to come in this call. Give him, and so at least I'll give already announced the first 3 speakers, so you can actually already click the button here, and then when the time comes, I'll give you access. So the first one is Marcus Spiegler, second one is Andreas Hedlund, and the third one is Chris McQueen. So all of you can already click the button, and then thanks. Okay, well, yes, there is Marcus.
It's working now.
All right, Marcus, are you ready? Anything you still need to prepare?
It's how to share the screen here. All right. So you see my screen now? Oh, okay. Great. Okay. Yes. Hello from Salzburg. I'm ready to start. First of all, I added a display to my data station, to the Arduino, so to use it also locally without a connection. And then I thought, because to solve a problem that I really love platforms like DataCake or let's say Grafana or something like that, but not everybody has this app or doesn't have to install this app. So I made a Arduino Makerbot, which sends the temperature and all the other data every 15 minutes to Twitter. Here you can see the display again. So for me locally, it shows the display, the data on the display. Temperature, humidity, pressure, elements, and stuff like that. And you can also use this for every other sensor. So it also has some warnings about heat and frost. So I did this with Node-RED, and I subscribed to the topic here from the network server, which is the topic from the sensor. Then I passed the JSON, and all the magic is happening here. So with this JavaScript, and if the degrees go below 4 degrees, it sends a warning, also frost, and about 35 degrees, it makes a warning for heat. And so I'm not able to change the temperature outside. I made some injections. So for example, I inject here the JSON with frost. You can see I send the temperature below 4 degrees, and everything is sent to Twitter. So from my perspective, this is a really cool, you can see it here, the warning is frost. Before I'd said normal conditions. And what's really cool here is because that everybody is able to use this, just follow this bot and have the local weather conditions. And for me locally, I just can use the display. Yes.
Cool. Perfect. And that was about 2 minutes. So thanks a lot for sharing, Marcus. Any questions or comments from Wienke or Luca?
No, it makes perfect sense. I understand what it is.
Yeah, I'm happy with this as well. Well done. Nice end-to-end.
Right.
Okay. Thank you.
Cool. Thanks a lot for presenting. Big round of applause for Marcus. So applause can be done in the chat. And then I would like to give the floor to Andreas Hedlund. I think I've already seen him here in the chat. So I'm gonna give you access now.
Hi from Sweden.
Perfect. Hi.
Hi.
Andreas, so go ahead whenever you're ready, and then I'll start the counter of 2 minutes.
Perfect, thanks. Let's start with the hardware. I'm in my greenhouse, as you maybe can see, and I have an irrigation system. You see the pipes there. But up until now, I haven't been able to see how moisture the soil is. So there's the Arduino. And there you see one of the probe. I have 4 probes in the water. So if I share my screen, the results coming into the console for the stack. And after that, I have a Home Assistant instance at my house and a local MQTT server. So I have bridged the local MQTT server to the stack's MQTT server. And then I'm fetching the different values and data. And if I take the probe that was in the water, I'm sending the data every 15 seconds right now for demo purposes. So that's 99% should be down to almost 0 in some seconds if everything works. Yes, 14. And then I get a push notification to my mobile when the moisture threshold is below the set value that I can adjust here. And also I'm able to do some downlink messages to perform battery saving. So it right now it just changes the time the low power sleep is enabled. So that's my case.
All right, that was also exactly 2 minutes. Really impressive. Anything additions from you, Luca, Winke?
It looks super cool. I really like the Home Assistant integration because that's a local instance, right? That's really just. Is it running on a Raspberry Pi or something, or?
I have earlier projects. I have sent data to DataCake, so that's also a possibility with this project. But for me, I like to collect all things in my Home Assistant to have it in one in all place.
Okay.
Have you also included or plan to include any control of the watering system through this, so it auto adjusts the watering?
Yes, but that's one of the limitations with LoRa. I need to connect it with Wi-Fi to be able to. If I do remote control of the valve that put the water.
If you look at the device repository, you have the Strega water valve. So that's the device listing on, and that is a LoRaWAN Class C water valve. Is it that, Lawrence?
Yeah.
And I also could do do it locally, so that it locally puts on the valve.
Indeed, my suggestion would be always think in the direction if you can have a local control loop, and through LoRa you more change the set point and the behavior versus doing real-time control, because that gives you sensible redundancy.
Exactly. In my mind, I had a thought that I should be able to push a button and manually control the water also. But that is also with the Class C device, as you mentioned, possible.
Wow, super cool.
Perfect. All right. Thanks a lot, Andreas.
Thank
you.
you.
Really impressive. So we go to the next presenter, which is going to be Chris. And after Chris, we go to Alf Magne. So Chris, once you are there, the floor is yours. Once you start with your presentation, I'll start the 2-minute timer. Good luck.
Okay, good morning, gentlemen from Ireland. I've really enjoyed this week. And I guess I'm very much novice, just getting into the LoRa space. I'm going to share my screen. If you could give me a heads up if you can see it. Yeah, you can see my screen okay?
Not yet.
No. No. I'm not going to be able to share it. Lawrence, remember the other day when I was trying to screen share with you, it wouldn't let me. The same thing again, just every time I try, it puts the red line through the monitor. Would you be able to get the presentation I sent you through Slack just up on screen, Lawrence, and I can talk through it?
Yeah, sure, we'll do. Once.
Sorry for the technical issues, guys.
No problem at all.
Should have pre-recorded. Okay, so this is a theoretical project, and to start with, then we had to have a real-life problem. So big in this area in Ireland is energy from waste, in particular the anaerobic digestion system, where you feed the anaerobic digestion plant whole crops, slurry, food waste, and then it produces biogas, biomethane from that. But a huge byproduct of that is the digestate, and it has to be stored in huge tanks. So at the bottom of the diagram at the top, the tank is a 10 million litre tank full of digestate, which then has to be irrigated and spread on land. So the problem itself then is that this is a manual process at the minute, where the guy just goes, kind of looks in or takes a reading of the level of that digestate, and then has to make manual decisions based on that. So there's several problems here, really. So there's the weather in Ireland. You're going to get wet as you go out. You walk around the farm and go down and check it. Human error, always, whenever somebody's registering a number or a figure or an estimation. And then there's also the health and safety aspect as well, that the more people you have moving around a farm, then the more chance of accident. So that's the problem that we have to address at the minute. Now, the solution, you can see at the top, is a waterproof ultrasonic sensor. And I've set that up through the Arduino board, through the thing stack, to take an hourly reading of the distance until the storage tank is full at the top, transmitted by a LoRaWAN, and then I have it sending to iOS. So iOS, or AWS rather, is integrated with the thing stack. So that's really it. Technically then, it's reading the MQTT. We can see that in the white area. I'm sorry, I can't give you a live demonstration, but it's reading that uplink, and that's really it. It's transmitting the payload, and then I can read the distance and then store it into the DynamoDB table. So for the future from that, I'm really playing about with this at the minute and trying to learn the technologies. But the future for a project like this would be the visualization of data and the collection of historical data, and then we're able to analyze the trends. And we can also use it for predictive forecasting of when the storage tank would need to be emptied, and then what farmland is available, what drivers we have, and so on and so forth.
All right, you got 10 more seconds.
Okay, we'll be able to use this data then to map it against the the feedstock that's going in, so we can then see input versus output and the changes that have been made. So they're very simple, but it's going to be very good for this industry.
Cool. Thanks a lot, Chris.
Okay.
So we discussed this yesterday, and I've seen it working at Chris's end. So I can share that as an addition.
Okay, it's not going to be a prize winner, but for me, it's a good learning experience.
Don't be modest. Don't be modest.
Cool. Any questions, comments from Winke or Luca?
No, it's super clear. It's very nice.
Yeah, very nice problem definition.
Yeah.
Thank you.
Right. Big round of applause for Chris. And whenever you're ready, we go to Alf, and after Alf, the next person to present is gonna be Veda Vyas, if I pronounce your name correctly. So whenever you're ready, Alf, go ahead.
Yes, thank you, Julie. Hello, my name is Alf. I will present to you the problem and the solution I have for this. So if you can see my screen now, I'll just take in a PowerPoint to show you. The problem is that a lot of salmon dies sometimes because of toxic aluminum from the river. And that is a problem all over the world where you have a river that flows into a fjord that contains some salmon farms. And it happens across sometimes, maybe not every year, but some years it happens. And the solution is to measure the salinity in the fjord and have a system that collects data about salinity and other parameters from the fjord and the river and on the salmon farm. So how to use LoRaWAN with this? I will use industrial sensors. I will use LoRaWAN EU controllers, sun panel powered, RAC 7248 LoRaWAN gateway, the TTE Stack V3, Balena Cloud, Webhook, and that Data Cake IoT platform. And I will show you now, how I have done it. So if you can see here, this is my Arduino module with a pressure transmitter into a bottle of water. So I'm measuring that, and through the system, I get it reading on my phone. So I use Data Cake dashboard from Data Cake. There I can see the water level and the battery voltage on the phone, on the sensor. And I use
10 more seconds, Alf.
Yes, I use I use the Balena Cloud to see the gateway. So thank you.
Awesome.
Perfect.
Yeah, super cool. Again, a really nice real world problem.
Perfect. Yeah. Again, very nicely, very specific problem with also quite a large impact in a specific industry. So these are the things we like.
Cool. All right. Big
Thank
round
you.
of applause for Alf. And the next up is Veda Vyas Naredi, if he is there. So please join in the call. And otherwise, the next one is Christoph, and I have already seen him. So I give you a few more seconds. Veda Vyas, and otherwise we go to Christoph. Ah, yes, there he is. Okay, the floor is yours whenever you're ready. No, we can't hear you yet. Yeah, that works. Perfect.
Okay, great. And I don't know how to share my document here.
So there should be a button with a screen at the bottom of your window. I'm not sure if you're on your phone, not sure if that works like that. I think it only works on your laptop.
Yeah, I'm on my mobile right now, not on laptop. I can't do it on a mobile, is it?
I don't think so, no. So you can either switch to your laptop and then we first go to Christoph, or you stick with...
Okay, so shall I join later with a laptop then?
Yeah, let's do that.
Okay. Yeah.
Then we first go to Christoph.
Hi, everyone. Can you hear me well?
Perfect. Yeah, we can hear you. So ready whenever you want.
Let me share my screen. Can you see my screen? Hello?
Yeah, we can.
Yeah, we can say.
Okay. Yeah. So hi, everyone. My name is Christoph, and today I would like to present the TTN Summer Academy Hackathon solution. So as we all know, in recent weeks and days in all around Europe, there has been a huge problem with floods. There has been just in the Germany alone, 10 billion euros in losses and 187 lives. And this happened because there is lack of reliable and local system to measure the river levels and send a notification to people who live around those rivers. So at Therapy, we actually have a solution. So you can see here, I have a sensor. This is a battery-powered sensor, wireless IoT LoRa sensor, cost-effective, that can measure water levels, including rivers and also lakes. It is based on LED time-of-flight technology. So what did I do for this hackathon? So I went around the area, found a local river, then crossed some bridges and dangerous places, make some tests, configured the sensor with the TTN network, make some trials. And then I tried to use the TTN mapper, which is an amazing tool. I didn't know that before. I used to use it and to find if the gateway location with respect to sensor was correct. And finally, I did some dangerous installation. Luckily, nobody died, so everything went good. And then create a dashboard on the data cake. And here I will go to the live demo. You can also click to that link. It's a public link. It should load soon, hopefully. It's loading. Let me see if that one works. There is some issue. Let me see. Oh, okay. So this is the live demo. On the upper left corner, you can see a water level, the real-time water level. You can also see a battery voltage, so you know when to replace the battery if the voltage is too low. You can also see historic data to analyze the trends and the raw distance measurement from the sensor. And clearly, when there is a threshold reached, the email notification is sent to local authorities, or it goes also send an SMS to people around to let them know that there is a danger incoming. Thank you.
Perfect. Thanks for sharing, Christoph.
Cool. Sounds great.
Any comments, questions?
No, makes all sense.
Yeah.
Thank you.
Cool. All right. Big round of applause for Christoph. And then we go, I think we give Veda Vias a few more seconds. And then the next two lining up are Pape Abdoulaye and Kobe Norit. So Kobe, I already see you here in the chat. So if you are ready, then I'd like to give the floor to you. Adding you now to the conversation. All right, Kobe, are you ready?
Yep. So morning, everybody. Here's my American presentation. Basically, it's the long distance remote sensor network. How do you deploy in a large sensor platform in a large area in rough terrain? Obviously, you don't want to hike up the canyon walls or swim out to the little islands all the time. And being in Texas, everything's a lot larger and further. Advantage is that it's very flat. So the real life scenario here is to do some water monitoring and environmental monitoring. So how do I protect my little clubhouse and my little fishing hole? Basically, I'm using an Adafruit microcontroller, 3D printed case with an environmental package on the side of it. I didn't have time to print out my little small floating sensor platform or a canopy to do in the tree. You have a base station somewhere located. One thing I found out that there's a really nice new packet radio that will basically go 50 miles. So basically you hook your Raspberry Pi gateway up to this, and then you'll have a hardline internet connection. It's slow, but for small packets, it's available. And then using how do you actually get it out to some of those remote sites? So I use a drone. So first thing you need to do is map the area to see where you need to place your gateways. So you can see here's the drone flying, so that you can go out there and using TTN mappers to actually see your range, and then know to go 1/3 less than that to put your next gateway, and then to actually drop off the sensors. Being a cheap sensor, if something happens, it's not as big of a impact, but you can fly it. And I didn't have the actual landing. I do have the video, but it was very grainy where you land, and it just releases the sensor. And then I have these smart little clips that are somewhat magnetic and then lock in, and then you can't pull it apart to do the retrieval. I'm using a 4400 milliamp battery, so I get plenty of distance or time with between battery changes. One thing we didn't really cover in this class, but I think it's fundamental to any IoT device, is Node-RED. It gives the functionality to your project to be able to do real action scenarios. So basically, you get your data that goes up to the TTN network. You have your MQTT transfer. You can put it in data cakes for review, but more importantly, you put it in Node-RED so that then it can send out or do functions, right, to move it.
All
And
right,
then
2 more seconds.
You also have Node data cake to pull the sensor location for recovery. So then you can sit there and map it, and it's about 5 miles or 4.5 kilometers between your MPR and then your sensors. Any questions?
Cool. Thanks, Kobe. Really
That's
impressive.
super cool. Yeah.
Yeah, interesting combination of technologies here.
Nice. Perfect. All right. Big round of applause for Kobe. Really impressive.
Awesome.
I think
Super,
that's
super
like
cool.
any available platform I've seen in your slide. So really, really cool to see. Thanks a lot. Pape, I'm going to give the floor to you.
Hi everyone, do you hear me?
Yes, perfect.
Yes.
Go ahead whenever you're ready.
Greetings from Dakar. I'll share the screen now. Okay, perfect. Can you see the screen? Okay, good. So thank you for having me, and thank you for this for giving me this opportunity to present the work here. So I've been working on a air quality monitor named called Hello DMC here in Dakar, in Senegal. And did you know that breathing in particle pollution can be harmful to your health, especially in developing countries like Dakar, Senegal? You can see here on the right the pollution air caused with dust during March, for example. So the main idea here is to propose a solution that will help avoid particle exposition for people that have that are vulnerable for health diseases, for example, asthma and other things like that. So the idea here is to deploy a sensors and to sense the PMS data, send it to a server, and then alert the person based on their location. So what I propose here is I build a device with the Arduino MKR, another Arduino Nano, and a PMS sensor that will send the data to a gateway, a LoRa-based gateway. The data is forwarded to the ThinkStack Community Edition network server, and then visualized with DataCat and in order to send some alerts. So I made a few tests this morning, so you can see here the PMS, the particle 1.0, 2.5 diameter, and 10. And then the next step is to send to set a threshold, and then based on the air quality index, to send people's notification when the air is polluted, and to avoid them to be exposed for air pollution. So I can also show you the device here. So I got the PMS sensor, the Arduino MKR with the N shield, and the Arduino Nano that collects the data, send it to the MKR.
Wow, awesome.
And
impressive. Thanks a lot, Pape. Any comments, questions?
Super clear and really nice solution. And yeah, it also has a very good real world problem.
Yeah, very clearly presented. So thank you.
Yeah.
Great. All right. Thanks a lot. And your dashboard really looked impressive. If I can add that to Link and Lucas' comments. So many thanks. So we go next to Rafal, and after Rafal we go to Robin.
Hello, good morning from Poland.
Getting you to the meeting.
Hey, hello.
Hi, thanks for having me. So I will try to share my screen and share my solution with you.
Perfect. Good luck.
Thank you. So my solution is a kennel environmental monitoring. The problem that I'm trying to solve is the efficient care for your pet, but it's aimed at breeders. So it's like where professional breeders, how they can look after and assure well-being of their animals. Values I'm measuring is the external temperature, external humidity, barometric pressure, internal temperature, internal humidity, internal CO2. I'm looking after 4 alerts, external temperature above 25. That's based on the dog we have. We're not professional breeders. My daughter is going to be one, but we kind of see application of this amongst also animal farmers. Internal temperature below -15 and internal humidity above 70 and internal CO2 above 1500 ppm. That's my client, our dog, Hardy Tatra Shepherd dog. The devices I'm using is the gateway, the Things Indoor Gateway. First sensor is ELSYS ELT2. That's the one. And the second one is ELSYS ERSCO2. Platforms is the ThinkStack Community Edition and DataCake. So now over to my application at the ThinkStack Community Edition, created for this purpose. We've got 2 sensors that are connected via webhooks to DataCake. And then we've got 2 sensors in DataCake, which are reporting live. And I have also set up those rules. This is the external sensor. So we're only monitoring external temperature. For this purpose, it's external above 25, because this dog we have actually is not coping very well with a higher temperature. But when we look at the internal sensor, there is a few more rules. because when it is actually within the kernel internal temperature, he can cope very easily with anything on -15. So that's why we're more concentrated on the lower end of temperature scale. Yep, that's my solution.
10 more seconds.
Yeah, that's my solution. Thanks for your attention, and good luck to all.
Yeah, super clear problem, super clear solution.
Yeah, thank you very much.
Thank you very much.
Thank you.
Perfect. Thanks a lot, Rafael. Very nice presentation. Cool to see that working dashboard as well. So big round of applause.
Thank you.
Then we go to Robin. Is Robin there? Yes, I see him. And after Robin, we go to Ricardo.
Hi, guys. Okay, so my real world problem is actually in the mines in South Africa. We have a lot of deep pit mines for platinum mining and coal and various other things. And we find out that a lot of the conveyor belts burn out and the bearings burn out. So if you have a look here, this is called a drive pulley. So the drive pulley basically has lots of things to monitor, one being temperature of the bearing and the drive shaft and the gear shaft. Also vibration of the actual motor. So what I've done is I've actually just built a quick little thing. So I've got my cloud, I've got a rack gateway. So all the problem is there's no, let me just show you, go here. So we got lots of problems in the mining industry. It's a large area to cover. Downtime is critical. There's no comms infrastructure, and most of the items are portable, so they move around. Machinery is not allowed to be modified. So the solution is use a standard infrared temperature sensor, and it's very low power. You connect it to your little LN50 trigger sensor monitor, and you've got various other devices to measure shaking and things like that with an accelerometer. So use a LoRa WAN. I've got a WAN gateway on my thing, so I send it to the gateway. Gateway's got a payload formatter. Then I've got live data from my thing, and then I've got data cake, and then my dashboard from that form. Then that's my conveyor information, and then I'm going to quickly just heat this up as a live demo. So I'm going to heat up the sensors with a heat gun, and then you'll see that basically I get a notification via email. We'll go back there as soon as it, because it takes a minute obviously for that to happen. So then that's so basically, yeah. So we've the actual problem with where we. So I'm just waiting for my email to come through, but it doesn't matter. It will come through eventually. The we're trying to get the ST32 to measure and do a spectrum analysis of the shaking of the motors and things like that. And you can't send lots of data. So what we do is we actually send that spectrum periodically every 5 minutes. So you only do a spectrum test every 5 or 6 hours. And to get all that data through, you need something like, I think, about 1,000 messages. So we do that once a day, and we get a full spectrum of exactly what's happening with the engine. And then you can schedule maintenance, because downtime is huge there. Yeah. So,
all right, a few more seconds.
So that's it. Yeah. Let's see if my so data cake, there we go. There's my alert. It comes through, it tells me I've got a problem. I click on the link and goes to the dashboard and gives you information. There you go.
Super cool. Very nice.
But there's, yeah, okay. So any questions, guys?
Well, very nice. This seems to have product potential. So talk to some mining companies locally, or if you're in
I'll
one.
just show you. I'll just show you something quickly. So all that there, okay, is what we have on the mines at the moment, okay, and we're replacing it with that.
Perfect.
So, well, I've only
That's a good
started.
addition to your pitch. Yeah.
Yeah, I only started IoT like 4 days ago. So that's what.
Yeah, that last bit was like, this is about simplifying the adoption, right? That is like, building a solution is too hard, but simplifying it for adoption is probably
super simplified.
even harder. Yeah,
it's going to save them $20,000 an hour.
Wow.
Yeah,
okay. I'm really impressed. So hopefully
Cheers,
Luca and
guys.
Vinke are so as well. So many thanks for Robin. Give him a big round of applause. And then,
Great for Luca for the Rhino stuff, because if you see my avatar, that's what I was doing last year, developing UAVs.
nice.
Perfect.
Cool,
Very
guys.
nice.
Cool. So do we have Ricardo already here in the chat? So feel free to join the meeting, and then I can give you access. And otherwise, we still have Klaus or Klaus and Vias if you manage to get your laptop to work. So also join in this meeting. All right, so let's go to Klaus first. So hopefully you are ready. I'm going to add you to the meeting now.
Okay, hello, can you hear me?
A second until you are there. Yes, okay. You ready?
Okay, yeah. Let me light an incense stick. You will understand later on, I hope, for what it's good. You can see the smoke. So, how to share the screen? Is this here? Can you see my screen?
Yeah.
Yes?
Yes, we can see it.
Okay, so this is a nice forest in California before and after a wildfire seized it, and this is my problem definition. I'd like to make some device and some solution to be more prepared for this. The device that I made up yesterday, called Forest Watcher. It has a particle sensor on the right top. You can see it has a humidity and temperature sensor, and this is the battery pack. And this is a system on a chip which contains a microcontroller and a LoRa unit. The idea would be to distribute forest watchers in the forest where they can be line of sight with the gateways, and they should monitor temperature and humidity, so to detect extremely dry situations before a fire can break out. We could close parks if long time there's a high temperature and low humidity. We can detect particles and smoke. So when a fire breaks out, there can be alerts. This can be combined with satellite solutions. When the fire is on, the system can provide safety information. That is, where is high smoke density, where is a lot of heat. This can be helpful for the fire workers to localize the heat, to localize with having in mind the wind direction. And afterwards, it can also be used to monitor if there's reignitions in the fire. The solution is the device which over LoRa connects to my gateway. The gateway forwards over IP the data to the Things networks. I used MQTT integration to InfluxDB. I have a local telegraph service which is getting the data, and finally I display it in a dashboard. The setup for testing is like you see here. I have I did this yesterday. I don't know if it works today. here have the incense stick, which simulates the fire. You can see maybe the fork goes over. Here's the device which should detect the fire, and this is the wind direction because my window was open. I'm not sure if we can now see this. This is the dashboard, and it's not since they are sending the data just once a minute. We're not detecting the fire yet. We see,
right, a few more seconds.
See in the above part, we see the different particle sizes. This goes up, and as you can see, yesterday I simulated the fire, and this was the response of the detectors, temperature and humidity detectors. So the system really is capable of detecting a fire. And just would like to thank all the organizers for this nice summer academy.
Looks super cool. Yeah, very clear. Thanks.
Thank you.
Perfect. All right. Big round of applause for Klaus.
This device, it's real.
Yeah, looks good.
It's real. Yeah, it's proof. Very cool. Very cool. So Ricardo, I saw you were there in the chat. So make sure you click there somewhere at the top right corner. There's a blue button with share audio and video. So if you click that button, then I can add you to this meeting. And after Ricardo, I'm going to give the floor to the team with Daniel, Manfred, Frank, Feng, and Alvaro. So, Ricardo, wait a second until you're added to the group. And go ahead whenever you're ready.
Hi, let me share my screen. Okay, first of all, thank you for this space. And this is some news that are shown in the newspapers of my country. For example, 68,000 claims from January to May due to excessive charges on electricity bills. Agglomerations due to claims for excessive charges on electricity bills. This is from November.
Ricardo, we cannot see your screen yet.
Okay. Now? Can you see my screen? Hello?
Yeah, we can see your screen. Yeah,
Okay.
The previous one. And which country is this?
I am from Ecuador.
Ecuador.
Okay. Agglomerations due to claims for excessive charges on electricity bills. This is from November 2020. Ombudsman preparing lawsuit against the state due to excessive charges on electricity bills. So there is a huge problem in my country with the electricity measurement. And why is this? The public company responsible for the energy consumption measurement admitted that have had problems and there are errors with the measurement of the energy consumed by the users. And how is the measurement get done? Their employees goes house by house taking notes of the readings of the electrical meters. So I present you Prometheus, quality of energy metering system that I have developed with one friend. And Prometheus consists in a digital electrical meter and an Arduino-based custom board with a LoRa module connected to first to TTN and now to TTI, and an interface for the user in DataCake. This is the magic. This is our custom-made board. And this is in a real case application. This is, for example, my house. And in the right is the device mounted. And now let me show you in real time. I have set this device that is constantly sending the data, just an status, if it's online or offline. And this status, you can see it in here. Every time it is sent the status, if it's online or offline. And in the dashboard, I have a button that makes a downlink to get the data, because the amount of data it's huge and it have to be decoded. And this is like all the amount of data that it is decoded. But for this presentation, I am just presenting the active energy accumulated, power factor, frequency, and the connect and disconnect. This is very important for my country, because actually we can help to the electrical companies to save a lot of money, because they are spending per user $6 per user just to connect and reconnect. And if we extrapolate that for hundreds of thousands of devices, we can make a huge difference. Thank you very much. That's it.
Very awesome.
Thank you. Interesting
Yeah,
problem.
thanks for staying up late. What's the time with you right now?
Excuse me, can you repeat the question?
What's the time? What's your local time?
My local time, 5 a.m.
Okay. Thanks for staying up late or getting up early.
Thanks to you.
Great use case.
Really cool, really cool. I think this also has a very clear business case, what you added there at the end. Nice. So the team. So first we have the team, and then if Veda Vyas still wants to try, then it's possible for you to join. So I'm going to give Daniel and Frank access to this meeting.
Hello, everybody.
Wait a second until you're there, both of you. And then whenever you're ready, go ahead.
So hello, everyone. I've just start to share my screen. Okay, it should be visible now.
Yeah.
So yeah, well, we have said COVID-19 pandemic, and for that we have a quite high interest in reducing the infection risk in closed rooms. And yes, that infection risk is based on aerosols in the air. And there's a strong correlation between aerosols and the CO2 level. So for us, it made sense to measure that CO2 level in closed rooms. And for that, we set up 4 CO2 sensors connected by LoRaWAN to the sync stack. And yeah, we measure it there. And from the sync stack, we have implemented 2 different integrations. The first one is quite traditionally based on a classical dashboard. I will just go to it. So here you could see our sensor readings from all of our 4 sensors. So that's a traditional approach based on webhooks and an SQLite database. And we also came up with a little bit more modern approach based on AWS. Here we have also implemented some Kibana dashboards, for instance. Let me just try to get you there. Yeah, so that's our Kibana dashboards there. And on AWS, we also have some integration with Telegram. So if the CO2 level in my room exceeds some specified threshold, we will also get a warning message sent to Telegram, and I will just try to trigger it manually. So let's see if it works.
Yeah, it will take some time, but yeah, eventually it will trigger.
It's already getting up quite high, so let's see. here it goes. So that's our solution, and we think so, especially with such an Telegram bot or with such alerting mechanisms, you can raise the awareness, yeah, to look after it, and yeah, maybe reduce the infection risk. So that's our solution.
Yeah, it was a adventure.
Yeah, and
last night.
Very nice.
We really learned a
last
lot of
night
things
even.
during that night.
Yeah.
Wow, awesome. Super clear.
Cool, big thanks. Any final comments from Luca or
Yeah,
Vinke?
thank you.
Super clear.
Okay. Yeah, it was a
All
good
right.
learning.
Big round of applause for Daniel and
Thank
Ronnie,
you.
and Feng and Alvaro and Manfred, who all supported this project. So Jamal, I see you tried joining this group, so I assume you would like to present as well, so let me give you access. And that will then be the final presentation. Oh, I think Jamal didn't eventually want to join. Okay, so that were all the presentations. So again, many thanks for everyone who is brave enough to present. I think that's already a big establishment. So next up, I will give Vinke and Luca a little bit of time to discuss and define who is the winner. So I will send you a link that you can use for the discussion. And I think we'll be back in probably 10-15 minutes. And so please stay here, stay tuned, grab a cup of coffee. And hopefully the people from the US or the Americas, so Kobe and Ricardo, they're able to stay awake for the final results. So cool, we'll be back very shortly.
Okay. Yeah, we can't hear you, Lawrence.
You're on mute.
For 2 minutes already. Oh.
He'll be with us shortly.
Oh, feel free to click off. Okay, he probably needs to. Yeah, Luca and I had a good discussion, and actually we were very much aligned. And yeah, first of all, I think what's really nice is that we have people from all over the world, people from Ecuador, from Texas, in Europe. And it was really nice that everybody was really solving a problem. So that was one of the criteria. The technical solutions that were built in a week were really awesome. It was really nice to see everybody using the tools. Yeah, we have one honorable mention, and Lawrence will also share a bit of what kind of prize there is. I think there's also a ticket to the conference. So Luca, maybe you can kick off with that, and then after that I'll announce the winner.
Perfect. Yeah. So I'd like to do the honorable mention to Alf for the salmon aluminium poisoning. Well, firstly, problem description and then the proposed solution. This is a very interesting concept, particularly because it's a very niche specific problem most of us are not aware of. It actually has a very significant impact on the specific industry as such, and really where IoT unlocks a possible solution, and also at a reasonable cost. So we very much like the problem description, the prototyping that was done, and that's why we would like to do the honorable mention to also give a bit motivation to go further with this.
Yeah. So congrats, Alf. Yeah, congrats, Alf, and yeah, indeed, great problem description and a great solution. So now going to the winner, and the winner is Robin from South Africa with the mine belt use case. And the reason why Luca and I were aligned on this is because we've been presenting the criteria. So first of all, it has to be a real world solution, and it has to be simple so it can be adopted. And following these criteria, this is a perfect match. First of all, the real problem that you have regarding this use case, but second of all, choosing a solution that is a retrofitting solution that doesn't need physical interference of these critical systems through infrared. Yeah, that's really the kind of engineering creativity that's gonna generate real adoption of these use cases, because you're really aware of the context and of what kind of domain and the problem domain you're working is. And I think that's really why this stood out. As I said, like everybody, I think every use case has one thing that's very, very special. So this is just the rules of the game, that we have to pick a winner. And we really liked all the others as well, but really Robin stood out. So Robin, congrats for winning this prize.
Yeah, congratulations from my side as well.
Yeah, can I take you to the stage?
Thanks, guys. Sure. I'm like ecstatic. I can't believe it. I didn't expect to win it at all. That's sure. I only started and decided to do this thing last night at 11 o'clock.
Okay, that's good.
So I started. I mean, I've only started in this job like literally like 2 weeks ago, and it's IoT has absolutely blown my mind, and I've learned a lot from you guys, and I always thank you. And it's extreme. You guys are just visionaries. You know, I might give some of my prizes away though to some people who I think are more deserving. So cool.
That's super nice of you. Again, congrats, and good luck in further developing the solution.
Thanks very much. Cool. I think my boss is going to be so impressed.
Okay, that's good.
He just asked me, what have you been doing all week?
no, you haven't.
Yeah, so okay, cool.
Nice.
Great.
All right. So
All right, great.
I'll shoot you an email today, and then I'll follow up next week, and then I would love to ship over the products. So for Robin, the T-shirt, the gateway, and a conference ticket. And for Elle, I'm going to give you a conference ticket and a T-shirt.
Thank you.
So again, many thanks, and I think everyone who made it this far in this course is, of course, a winner. With their
I agree, 100%. Yeah.
All the gifts.
Yeah, Nick, I already just got a pay rise, man.
Great. Okay. Many thanks for joining in. So also give a big applause for the jury. We highly value your input here. And of course, like Robin and Alf, and of course, everyone who participated. So this is only the beginning, and this is only what you can manage to do in a few days of work. So can imagine if you really spend some weeks or months and really further develop your work. So hopefully you all get an idea of how this works, and it's like a big start for further development. So again, big thanks. So in 10 minutes, we have a very short round-off video on stage, so make sure you check it out. And again, big thanks for everyone who joined in.
Yeah.
All right.
Hey, see you guys.
Thank
Enjoy
you.
your day.
Bye.
Have a great weekend. Bye.
Cheers.